It's George Tyndall, and I'm back again. And I'm here to explain a few things. It takes a while when you don't have the equipment that you really need, and people don't want to believe, and that's fine. But I have to go and I have to research things, I have to look things up, and I have to figure things out. And then I have to come to a conclusion with what I have. Okay, now scientists largely base their understanding of Earth's geohistory. It's from James Hutton on March 4th and April 7th of 1785. He presented his theory of Earth at the Royal Society of Edinburgh. Okay, now scientists base a lot of the geological science off of something that was done in 1785. And this is the point that I'm trying to get across to people. People need to go back and they need to look at some of this stuff and research it. But that's that. Okay. Now I'm going to talk about Libyan desert glass. Okay. Silica is not found in pure isolated form on the Earth's surface. Libyan desert glass is 98% silica. Okay. Libyan desert glass has a melting point of 2,912 degrees Fahrenheit. Now, there are a couple different ways that they think this is made of. And I'm saying it needs to be one way, but there's a couple different ways. Libyan desert glass is a specific type of impact glass. Okay, now they say it was made of impact glass, formed by a meteor impact in the Sahara Desert. Okay, that's one. The other one is an airburst explosion in the air created Libyan desert glass. Okay, so here we have two different things. And this is what they're teaching people. There should only be one way. Now, formation of this glass is to be when meteor impacted the Sahara Desert, melting surrounding sand into glassy material. Okay, now that sounds all fine and good. But when you start looking things up, now, fusion crust is largely made up of silica-based glasses. Now, for my honest opinion, what I'm finding, the Libyan desert glass, it doesn't come from impact. And I'm going to tell you why it doesn't come from impact. Okay. Glass is made at 2,550 degrees Fahrenheit and up. When a meteor hits the ground, its outer surface is not hot at all. That's what it says. Okay. Now, if its outer surface is not hot at all when it hits the ground, and sand has a melting point of 3,090 degrees Fahrenheit, how is the glass made if the meteor isn't 3,000 degrees on impact? And this is the point that I'm trying to get across. This stuff doesn't make any sense. But what will make sense is what I'm going to explain and what I'm going to show you. It makes far more sense than this BS that they're shoveling to everybody out there. When you look up melting points and how hot things have to be, yeah, the recent meteors that have hit the ground, oh yeah, they just baked the ground. I haven't seen any of that. And this is all getting to be a bunch of nonsense. Now, what I'm going to explain here is what I think happens from what I find. Okay. This is what I found in the ground. This is, you're supposed to be your Libyan desert glass, but it's found in Woodland, Washington. in the ground. I dug it out of the ground. Now, pictures look different, so I'm going to show you the piece. Because when the light is on it different, it's pictured different. This is yellowish green. And when a brighter light is put to it, you get a more greenish color. Okay. Now we're going to take this little glass piece, this little piece of Libyan desert glass, which is 98% silica. Now I'm going to show you where this stuff comes from. When your rocks come in, your meteors, and they're abnormally shaped, and on the front, when everything starts melting and gets pushed back, you're going to have uneven areas like this. And you're going to have areas like this hole. Now, when everything's pushed back, the silica is going to build up in this area. And it's going to clump up into the bigger the blockage there for it not to be able to blow over the top of it. The bigger the blockage, the bigger the piece of glass that you're going to have. It's no different when this comes in and it starts to melt. Okay, this hole, that silica is going to go right down in the hole. That silica composition. Okay, and this hole is going to be packed with silica, and this area right here is going to be packed. But when the meteor explodes, the silica is going to blow off into all sorts of pieces. Now, because fusion crust is a whole glassy piece, the silica probably bunches up into a big, huge piece. And then when the meteor explodes, that stuff goes everywhere. And I'm not so sure that they're just produced by meteors. I think more of the silica comes from comets. I think some of it comes from meteors, and I think some of it comes from comets. But, you know, like I said, you know, people want to do what they want to do. They want to believe what they want to believe. Now, here's another picture. This is silica glass on the outside that's built up. It's basically the same as this, but it's spread out, it's thinner. I'm telling people as it is and as I'm finding it. Now, why did I find a piece of this in the ground? Oh, well, because maybe Libya was part of Woodland, Washington at some time. And this is how asinine and stupid science is. And people don't want to listen, they don't want to believe, they don't want to go back, and they don't want to check things. Nobody wants to search for a whole rock. Nobody wants to search for comet fragments. So I'm going to tell it like it is. And I'm going to continue to tell it like it is. Because nobody's going to come out and nobody's going to challenge what I have to say. And that's the bottom line. Because they don't want to. Nobody wants to get out their butt. Everybody just wants to sit there, take people's words for it. Because this guy said, this is the way it is. Or because he took a picture, that's the way it is. Now, I'm going to explain comets. And I'm going to explain to you why they're off on comets. Now, the Rosetta mission. The Rosetta mission drilled 23 centimeters into the comet, which is 9.055 inches. 9 inches into the comet. And you're going to tell me that all the way through that comet is the same composition you drilled 9 inches in. And let's look at the Earth. Okay, here we have the Earth. We have the core. If I drill 9 inches into the Earth, am I going to get the same reading at the center of the core? The center of the core is going to be different. And the outer layer that runs around the core is going to be different. And as you go further up, everything's going to be different. Now, on a huge comet, let's say the comet was 200 miles wide and 16,000 miles long. If you just drill 9 inches in, you're not getting the full picture. You don't know what it's composed of on the inside just because you drilled on the outside. And it's frustrating. It's frustrating that experts out there can't see this. Now, I have an idea what a comet really looks like because I've been doing my research and looking up things and finding things. Okay. Now, they say a comet's 55% silica. Okay, the Earth has a high silica amount too. Okay, so you would have to figure if the Earth was created with a high silica amount, if a comet's 55%, the Earth's got to be probably a good 55% at least. And probably some of the asteroids, because if the Earth was made with parts of comets, asteroids, rocks, everything that blew up, supposedly what they say, it would have to have a high silica content, so the rocks in space have a high silica content. But it's not just in silica, it's in silica minerals and things like that. Now, the Libyan desert glass, going back to that real quick, and the reason why I believe what I believe on that, why meteors don't make that stuff, is one, you didn't find a whole bunch of that stuff around the Hoba meteorite, or the Willamette meteorite, or a lot of the other meteorites that have been found. Now, let's look at the large meteors, okay? Cape York meteorite, not deeply buried, okay? The Campo di Cielo, 16 feet deep. The Altari, on top in the strewn meteor field, on top. Okay, so these meteors aren't impacting the ground like the scientists seem to think that they do. The Hoba meteorite really left no crater, and it goes on and on and on and on and on. These meteors aren't going deep into the ground like people think. When they come in, they go boom and they hit the fucking ground. I mean, when they go boom and they hit the ground and everything, you know, they say they kick up all this dust and the explosion and everything. Well, we've seen meteorites, little meteorites hit the ground, and we're not seeing any of that stuff that they're telling us. Now, who is right on this stuff and who isn't remains to be seen. But if you look up everything, you look up, and you'll find. Now, comets, from what I can tell, yes, the ice thing, I don't buy the dirty snowball thing. Yes, they have ice, they have water, stuff like that. But they also have silica sand, orange olivine, white silica, which is fairly high in it, iron and nickel. Comets do have iron and nickel. Feldspar, probably orthoclase, plagioclase, and potassium feldspar. Zinc, sulfur, sodium, and potassium. Now, when you mix a lot of those things together, certain mixtures are going to explode. And that's probably why your meteors and your comets explode, is because of the mixtures. Now, I'm going to show you, okay? I'm going to show you this piece, okay? This is what a comet looks like, whether people want to believe it or not. This side is melted. This side isn't. And this thing is packed with green and orange olivine. And also other things. But the green, the massive amounts of green in the orange olivine gives it this color when it mixes. When it mixes with the white silica, orange olivine, and green olivine. You take those, look those three colors up, and you mix them. What do they make? It's the same way. It's the same way with these stones when they turn to stones. When the olivine turns to peridot or whatever color that is, it's going to mix in, and it's going to cause this to change color. Now, this is more like a fragment that was either blown off a comet because it's melted on one side, or it had a problem in the mesosphere being able to melt the rocks, which I've been trying to explain to people. There's a serious problem there, but like I said, they don't want to listen, and that's fine. It either was blown off, it hit it impacted the ground and broke off another rock, or when it came through, this side was the side that came through, and this side was the side that heated, and this side didn't even heat at all, which is very possible from some of the burn marks and the melting marks that I'm finding on some of these rocks. Now, here we have all the same. This is all the same. Every one of these is the same. Okay? But ones like this are darker because they got hot. They heated longer and they burned longer. They absorbed way more heat. That's why it's really black like that. And this one's a little bit less black, and you can see the outer part, but when you compare it to this large piece, it is the same. That is the same. Now, a lot of people go and do whatever they want. No, I don't care. I'm putting my findings out there. Now, what I believe that a comet does, this is what I believe a comet does and why it's so bright, is when it's traveling, it goes to a form like this. Everything crystallizes into quartz. And as you heat it more and more and more, and you go above quartz's melting point, you end up eventually getting cristobalite. Above cristobalite, you end up with things like powders and gases. When things get to a certain point, they turn into a gas. And this is your science. Now, if that's the fact and this is true, this stuff right here, when held up to the light, is really bright. Okay, so the closer it gets to the light, the brighter it is. I believe that the silicates and everything that melts on it, the silicates, the iron nickel, the green olivine, the orange olivine, when all that melts, that pushes backward off the comet and eventually turns into silica gas or whatever. It could be a combination of gas and silica powder. I don't know. I just happen to guess the stuff. But that makes more sense if the silica or the trail coming off it wasn't just all ice and dirty snow and stuff like that, what scientists say. Me personally, I think a lot of the ice and the water and stuff would, on a sun grazer comet that gets within 1 million miles of the sun, would have been long gone by the time it gets in with that 1 million miles of the sun. Okay, so what are you left that's making a comet trail? It's got to be something else. But like I said, this is just my findings. And different ones get heated to different points. Now, this was heated differently too. This was heated differently than this one. You can see the difference. This is totally black. I cannot get this black off of here. This one I was able to clean up a little bit. These are a little bit blacker, but And this one has black on it too. But that is my findings. Okay, now scientists out there, they're not going to like it. They're not going to like it. They're going to disagree with it. Well, the spectroscopy that they use to determine a lot of things, it's wrong. It errors. Okay, spectroscopy does have errors. You can look it up. And if you're using equipment and you don't know 100% sure the tests that you're doing are right, this is when you run into a problem. And this is what I'm trying to explain to people. Now, whether people want to believe it or not, you don't have to. I'm telling people what I'm finding. And what I'm finding doesn't add up to what a lot of the scientists out here are telling everybody. And I think I'm going to call it good at that point, because anything else that I tried to explain, nobody really wants to believe, but they don't really want to listen. They want to listen to what some guy said in 1785 and consider that the law. But you people are smart out there. You be the judge. You think you should be going information that was in 1785? Findings that were posted in 1785? Or should you do it now and re-go over it and re-look things over with the science and technology we have now? I think that's the smartest way to go about it, but the scientists that we have that get educated and everything, they want to continue to go by the old way. And the old way has errors, and I'm just trying to explain this to people. We'll call that good.